Hello everybody. In this short lesson, we will look at the differentiation of trigonometric functions. Um, the most common trig functions are sine, cosine, and tangent. We have cosec, we have sec, and so on and so forth, but we are going to focus our attention primarily on the primary trigonometric functions, which are very common in physics. You will actually use this when you go to oscillations, simple harmonic motions. And this is really indispensable in understanding in knowing how to analyze systems that oscillate simple harmonically. For example, if y is equal to the sine of x, then y prime will simply be cosine of x. That's simple, right? If y is equal to cosine of x, then y prime will simply be negative the sine of x. Now, if y is equal to tan x, remember tan x is the same as sine x divided by cosine of x, then y prime will be equal to sec square x. Now, these really are the primary trigonometric functions. The next scenario would be for us to know how to differentiate trigonometric functions or functions. Let me give you an example. If y is equal to the sine of f of x, then y prime will simply be equal to f prime of x cosine f of x. Let me give you an example. For example, y is equal to sine of 2x plus 1. This would mean that y prime, this is right here, this is our f of x. So f prime of x is just 2 cosine 2x plus 1. Let me give you another example. If y is equal to sine x squared, this implies that y prime will be equal to, in this case, this is f prime. This is f of x, so f prime of x is just 2x cosine x squared. And this will be our answer. So we have here, this is 1, 2. If y is equal to cosine of f of x, this would mean that y prime will be equal to negative f prime of x sine f of x. So take note about this, and take note of the negative sign, because most students in my experience always seems to forget the negative sign. Remember, the derivative of cosine is negative sine, and the derivative of sine is positive cosine. Now the reverse will be true when we go to integration, but always remember this: the derivative of cosine is negative sine. So let me do another example. Similarly, anyway, let me do an example before we proceed. Y is equal to cosine of, let me say, 3x cubed plus x. This would mean that y prime, this would imply that y prime, or we could say that if you want to follow step by step, let f of x be equal to 3x squared plus x. Therefore, f prime of x is equal to 6x plus 1. Hence, y prime, which is equal to f prime of x, well, negative sine f of x. So this will be equal to negative bracket 6x plus 1 sine 3x squared plus x. And that gives you our answer. Another example that I would like to do would be y equal to 2x sine x. So we should look for y prime. This is a product. You can say that let u be equal to 2x and v be equal to sine x. So this would mean that u prime is equal to 2 and v prime is equal to cosine of x. By the product rule, y prime is equal to u v prime plus v u prime. Hence, y prime in this case will be u, which is 2x, v prime, which is cosine of x, plus v, which is sine x, u prime, which is 2. So this is 2 sine x. You can further factorize, take out the 2 because the 2 is common, and you're left with cosine x plus sine x, and this will give you your answer. And that will give you your answer. Now lastly, if we have, let's do another example. Let me say you have y equal to the tan of 3x plus 1. You can say that let f of x be equal to 3x plus 1. This would mean that f prime of x is equal to 3. Now y prime is equal to f prime of x sec square f of x, which is going to be equal to 3 sec squared bracket 3x plus 1, and that will give you your answer. Now so this right here gives us the essential of trigonometric differentiation. But before we move forward, let us do one more example. Suppose that h of x is equal to sine e of x. Let's look for h prime of x. In this case, what you can do is you could let f of x be equal to e of x, which means that f prime of x is just going to be e of x. Now, by definition, h prime of x is just going to give us f prime of x cosine f of x. So this is equal to e of x cosine e of x, and that will be our answer. Or another example would be, for example, h of x equal to 5, or let me say ex cosine x, and we are expected to look for h prime of x. So this is a product actually, and we will imply or use the product rule. We could say that let u be equal to e of x, which imply that u prime is just going to be e of x. Let v be equal to cosine of x, which implies that v prime is just going to be equal to negative sine x. Hence, h prime of x will be equal to, if you remember the product rule, it's right here. So you will have here vu prime. So this is going to be e of x cosine x minus u, which is e of x sine x. So we can further simplify. H prime of x will be equal to e of x bracket cosine x minus sine x. This is our results. Now, in the next couple of examples that I'm going to do will just be for us to to use the product rule over and over so that we can become used to it. So another example would be, let h of x be equal to 3x squared ex. We are required to find h prime of x. This is a product. This is the first function. This is the second. So we could say that let u be equal to 3x squared. This would mean that u prime is equal to 6x. Let v be equal to e raised to the power x, which means that v prime is e raised to the power x. Then h prime of x is uv prime plus vu prime, uv prime plus vu prime. So we're going to have here 3x squared e raised to the power x plus vu prime, which is 6x e raised to the power x. And we can actually simplify that. H prime of x will be equal to x e, well, we could take out 3x e raised to the power x bracket x plus 1. And this right here, my friend, is the solution to our problem. Sorry, this is 2, not 1. It's the solution to our problem.